All right, guys, back to our trig unit, finding trig functions of any angle. So there are actually 6 trig ratios. I know 3 are kind of much more common than others. There's the sine ratio, cosine, and tangent, of course, are the 3 big ones. But there are 3 others, okay? And the deal is that they're really just the reciprocals of these 3. So that's why they're not even covered all the time, especially at the beginning, because basically any problem that would involve one of the other 3 can be found by just doing a reciprocal and using one of these. So anyways, let's just kind of do a real quick recap of what these are, and then talk about their reciprocals and their names. So again, if you have let's just put something on the coordinate plane here. Let's say you have a triangle like this, boom, boom, and here's our little angle theta. Okay, and of course, like before, we have an opposite side, we have an adjacent side length, and we have a hypotenuse over here. Okay, of course, hopefully we're familiar at this point that sine is always just the opposite side length over the hypotenuse. Cosine, of course, is the adjacent side over the hypotenuse, and tangent is opposite over adjacent. Okay, so just to introduce, before I get to the other 3 ratios, just a little different way of thinking about these. A lot of times once you get past just right triangles and you start opening this up to being larger angles in any quadrant, basically, the idea is you think of a point on the terminal side of the angle. Okay, the terminal side of the angle is the hypotenuse over here. So if you know that the coordinates of that point, the idea is that the adjacent side, no matter what quadrant you end up with, if you remember the reference angles, the adjacent side is always going to be the x-coordinate, because that's measuring horizontal distance from there to there. The opposite side from there to there will always just be whatever the y-coordinate is. And then what we're going to do is call the hypotenuse, we're just going to call that r. And the reason for that, it's basically the radius of a circle. If you think about the unit circle, or other than just any circle, basically just kind of going around like this for this specific example, but the hypotenuse will always end up being from the center of the circle to the edge of the circle. It'll just be whatever the radius of the circle is. Okay, so thinking of things that way, sine can now be thought of opposite over hypotenuse. You'll sometimes see referred to as just the y-coordinate over r. Cosine will just be the x-coordinate over r, and tangent will be the y-coordinate over the x-coordinate. Okay, just kind of applying these new labels to those things. Okay, now we'll do a few examples with specific numbers in a second here, but the other trig ratios that we need to be familiar with and we're going to be seeing are the reciprocals of these. So the cosecant, the secant, and the cotangent. Okay, so cosecant, secant, and cotangent. And really, like I was saying, they are just the reciprocals of one of the original 3. So sine actually gets paired up with cosecant. Okay, so that means that cosecant is really just going to be, instead of being opposite over hypotenuse, it is hypotenuse over opposite, okay, or r over y. Okay, secant goes with cosine, so it is the hypotenuse over the adjacent, okay, or r over x. So those kind of get paired up together. And I always thought those kind of seemed backwards, right? You'd kind of hope that cosine would go with cosecant. But they do with other things. There's other relationships, but they are not reciprocals of each other. Okay, secant goes with cosine as a reciprocal. Cosecant goes with regular sine for its reciprocal for whatever reason. Now tangent does do what you would hope. The reciprocal of tangent is cotangent. Okay, so those 2 do kind of match up correctly. The other ones, I mean, if you just kind of remember, they seem to be flipped. But cotangent then would be the adjacent over the opposite. Okay, also could be written as the x-coordinate over the y-coordinate. Okay, so just kind of keep those in mind. Remember, sine and cosecant go together. cosine and secant go together. And then tangent and cotangent do fortunately go together. Let's see if we can answer some questions about these. All right, so let's take a look at what are known as these quadrantal angles, and these are like your borderline angles. So your 0, your pi over 2, okay, 90 degrees, the angle at pi or 180, and then the 270, which is 3 pi over 2. So if we think about, again, we have this nice little circle. Let's pretend this is the unit circle with a radius of 1. It just kind of makes our calculations nicer. The coordinates of all of these points, so the one over at 0 degrees, it's 1 unit to the right of the origin. So if the radius is 1, it would be 1, 0. Up here at pi over 2 would be 0, 1. At pi, we would have a negative x value and 0 for y. And then over here, we would have 0 for x and negative 1 for y. Okay, so if we want to list there all the trig ratios there, the sine of 0, the cosine of 0, and the tangent of 0. Okay, again, if we just remember on the unit circle, the sine of the angle is just the y-coordinate. The cosine of any angle, the adjacent is the x unit and the x-coordinate, and the tangent is the opposite over the adjacent, so y over x. So that kind of holds for all. And since this is on the unit circle, notice there's no denominator, because again, on the unit circle, the radius is just 1, okay, or the hypotenuse is just 1. All right, so the sine of 0 degrees is just the y-coordinate here. So here's the y-coordinate. So the sine of 0 is 0. The cosine of 0 is just the x-coordinate, which is 1. And then the tangent would be y over x, 0 over 1, which is just 0. Okay? For the reciprocal functions now, okay, remember the 3 reciprocals? We had cosecant, we had secant, and we had cotangent, right? So these are kind of the special ones here, okay? Sine of 0 equals 0. So the cosecant is the reciprocal of that. The reciprocal of 0 is undefined. Okay? Cosine, if we remember, if we think about the actual coordinates, the cosine is the x-coordinate there. It's 1. So the secant will be the reciprocal of that. It'll be 1 over 1, which is still just 1. Okay, and then cotangent, okay, remember if tangent is 0 over 1, the cotangent will be its reciprocal, okay, which would be 1 over 0, which is actually undefined. So if the original function is 0, the reciprocal will be undefined. Okay, so there's all of your what are those called? Those are the trig values for the quadrantal angle of 0. Okay, let's do one more. Let's do the 3 pi over 2. Let's do all 6. So for this angle down here, let's do sine of 3 pi over 2, cosine of 3 pi over 2, tangent of 3 pi over 2, and then we'll do their reciprocals as well. So sine, again, is just the y-coordinate. Okay, so just looking at the y-coordinate, okay, right, here's the x and y coordinates there. So the y-coordinate there is negative 1. So that's the sine of 3 pi over 2. The cosine of that angle is the x-coordinate of 0. And the tangent is the y over x. Okay, in this case, negative 1 over 0. Okay, 0 in the denominator makes the expression undefined. Okay, then the reciprocals, the cosecant of 3 pi over 2 needs to be the reciprocal of negative 1, so it would be 1 over negative 1, which is still just negative 1. Okay, the secant of 3 pi over 2 is going to be the reciprocal of 0, so it would be 1 over 0, which is actually, of course, undefined. And then the cotangent there, the cotangent of the angle would be the reciprocal of negative 1 over 0. So it would be 0 over negative 1. And when the 0 is in the numerator, it makes the expression equal 0. Okay? So that's kind of the thought on those. Sometimes it helps just to write them as the y over x and all that stuff, and then just think about reciprocal means, of course, just flip the fraction or put a 1 over it if it's just a whole number. Okay, so you could do the same exact process with the pi angle and the pi over 2 angle and kind of figure out those. Again, those are called quadrantal because they're like right on the borderline. All right, now let's talk about the actual trig ratios by quadrant. Let's say you're not right on the x or y axis, you're kind of out the middle of a quadrant somewhere. So just remember again, coordinates or quadrants, I mean, go this way. That's 1, that's 2, that's 3, and that is 4. Okay, and the other thing just to keep in mind again, remember that sine theta always gets associated with the y coordinate because it's the opposite. Cosine of any angle gets associated with the x coordinate because that's the adjacent. And then tangent, of course, does opposite over adjacent, so y over x. Okay, so if we think about that, and you think about, let's just say there's a point here somewhere in quadrant 1, right? Whatever it is. In quadrant 1, there's a reference triangle in quadrant 1. The x and the y coordinates are both positive. Okay, so that means any angle in that quadrant will have a positive sine value, a positive cosine value, and a positive tangent value. So let's just think of a way to write this. Sine of the angles will be positive, cosine of the angles are positive, and tangent of the angles are positive. Okay, but if you move over, let's say your terminal side ends up somewhere in quadrant 2. Okay, so your reference triangle would end up being something like, in quadrant 2, there's your terminal side, the x-axis always becomes the adjacent, and here's the opposite. Okay, so if you had a triangle over there, there's your reference triangle. If you think about the coordinates there, okay, I'm going to ask, are the sine, cosine, and tangent positive or negative there? Okay, so if you're sitting right here, the y coordinate, okay, which would be this length right here, is still positive. Okay, so the and one trick to remember, the hypotenuse is always positive. Okay, but the y is positive in quadrant 2, so the sine of any angle there is going to be positive. But the cosine, if you think about this length, okay, technically it's going in the negative direction, so the adjacent side, even though length can't be negative, it's kind of in that direction. So if you're in quadrant 2, the cosine of the angle will always be negative. So if you have an angle like something bigger than 90, in between 90 and 180, if you're doing the cosine of 100 degrees, for example, it's actually going to be a negative number. All right, and then tangent being opposite over adjacent, being y over x. If you're in quadrant 2, the y coordinate's positive, but the x is negative, so that makes y over x also going to be negative. Okay, in quadrant 3, let's think about, are the x and y coordinates positive or negative? So in quadrant 3, the y coordinates are negative, so the signs are negative. The x coordinates in quadrant 3 are also negative, but tangent then, if it's negative over a negative, the tangents are actually positive of a quadrant 3 angle. And that's kind of the weird one. Everyone thinks everything's negative in quadrant 3, and it's true. X and y are definitely both negative, but tangent being the ratio, it'll be a negative over a negative, would still end up being positive. Okay, and then in quadrant 4, so in quadrant 4, the y coordinates are negative, right? And what I'm doing when I'm saying this, I'm just imagining, let's say there's just some point sitting there, right? Its y coordinate would be negative. So it's the sine of the angle would be negative. But the x coordinates in quadrant 4 are all positive. And tangent is the y over the x, the sine over the cosine. So one of each makes tangent negative. Okay, so that is the little pattern there. All the reciprocals have the same sign as their original function. So wherever sine is positive, cosecant would still be positive, and so on. Just flipping a fraction would never make it negative or change its sign. Okay, so just think about those. There's going to be some questions where they say, what quadrant is tangent negative? And you're going to say, well, quadrant 2 and 4. Okay, or sometimes you're going to have to draw an angle based on a condition, knowing which quadrant it goes in. And that's really all I'm thinking about on these is just think about the x and y coordinates of a point in that quadrant. All right, so let's take a look at an example here. Given that the cosine of theta equals 2/3 and tangent of theta is less than 0, can we find cosecant of theta? Okay, so let's think about what do we know? Okay, so cosine being 2/3, right? So that's telling me cosine, of course, is the adjacent over the hypotenuse. Okay, now here's the deal with these. We have to make sure we get in the right quadrant. Okay, because cosine equaling 2/3 could either be a triangle like this, where our angle's here, and the adjacent is 2, and the hypotenuse is 3. Okay, or cosine could also be positive 2/3 if our triangle was here, and that adjacent was 2, and the hypotenuse were 3. And the actual angle for that option, again, standard position would be this way, but we would be using the reference angle of this little guy here because that's how we could get a right triangle drawn. So we need to figure out, are we in quadrant 1, like the first option, or quadrant 4, like the second option? Okay, and that's going to, make a difference in what we do when we need cosecant for our final answer. So, okay, because again, just remember with these, the hypotenuse is always positive. Okay, so no matter what quadrant you're in. So that's why if cosine is positive, it means the x needs to be positive. Okay, and that happens in quadrant 1, like this guy, and quadrant 4, like this guy. So what I'm going to look at now is that they're telling me this other condition, the tangent is negative. Okay, so in quadrant 1, if you think about the triangle, the opposite and the adjacent, the y and the x are both positive. So tangent would be positive there. But in quadrant 4, the opposite is negative and the adjacent is positive. So we need to be dealing with this side because that's where tangent would be negative. Okay, so this didn't meet the conditions. So now that we know what quadrant we're in, we're going to think about cosecant of theta. We know cosecant is the reciprocal of sine. Right? That's kind of what I'm thinking. So sine is opposite over hypotenuse. So cosecant will be hypotenuse over opposite. Okay, so we're just going to use the triangle that we drew. Okay, we know the opposite. Actually, we don't know the opposite. We know the hypotenuse is 3. We need to find the opposite. Okay, so let's do a little Pythagorean theorem here. We're going to find this y value here. We're going to say that 2 squared plus y squared equals 3 squared. Okay, so 4 plus y squared equals 9. That means that y squared has to equal 5. Okay, so y could either be plus or minus the square root of 5. Okay, based on our situation, it's got to be the negative value. Okay, since we're in that fourth quadrant, right, the y value needs to be negative square root of 5. And then that means our solution, the cosecant of the angle, the opposite side is negative root 5. And the, I'm sorry, I wrote that wrong. The hypotenuse was 3. Let's erase that. Hopefully you guys caught that. Just testing you there. The hypotenuse was 3. The opposite was negative root 5. Okay, now we do need to rationalize that. We can never leave square roots in the denominator. Okay, it's a big no-no. Really bad. Okay, really bad. So we can multiply top and bottom by square root of 5 and get our final answer of 3 root 5 over 5, and the entire thing is a negative value. Okay, that would be the cosecant of the angle that met the conditions. All right, let's take a look at another example. Let's say we're given that cosecant of theta equals 5 and that cotangent of theta is less than 0. Can we find the remaining trig functions of theta? So first off, again, I don't really like working with these reciprocal functions all that much. So if cosecant of theta equals 5, what that's telling me, kind of indirectly, cosecant again is the reciprocal of sine. So I know that the sine of the angle must be the reciprocal of 5. so 1/5. So that might just be a quick conversion just to make things a little more easy to visualize. Okay, now the other condition, okay, because again, there's kind of two quadrants where it's possible. If cotangent is negative, let's think about where we are. Okay, first off, sine would be positive wherever the y-coordinates are positive, so quadrant 1 and quadrant 2. Okay, so now the other condition is telling us cotangent is negative, so that means we must be in quadrant 2. Okay, because cotangent, again, goes with tangent, and tangent's positive in the first quadrant, but it's negative in the second. So our angle, our actual real angle, theta is somewhere in the second quadrant. This is theta. What we're going to do is use the reference angle, same terminal side, and use the x-axis. And this is not drawn to scale or anything. This is just going to be our little visual. There's our reference angle. Okay, and I'm just going to set up that triangle with the ratio that they gave me. Sine equals 1/5. That means the opposite side is 1. That's always the vertical side. And the hypotenuse is 5. Okay, so in this case, we don't know the adjacent side. We don't know x, but we can find it, again, using Pythagorean Theorem. And just keep in mind, we're going to go with the negative value of it because we are actually in quadrant 2. Okay, so the Pythagorean Theorem would say that x squared plus 1 squared equals 5 squared. Okay, so x squared plus 1 equals 25. Okay, let's pick this up here to save some space. Subtract the 1 from both sides. X equals 24. I'm sorry, x squared equals 24. So x is going to be, we're going to use the negative this case, negative the square root of 24. And I do want to simplify a little bit. I'm going to do 4 times 6 because 4 is a perfect square. Okay, so we're going to have negative 2 root 6. That's going to end up being our adjacent side, the x coordinate. So it's negative 2 times the square root of 6. Okay, now that we know all the side lengths in the triangle, we can go ahead and get the other ratios. So just to list all 6, I guess sine theta we knew was 1/5. They originally gave us cosecant theta equaled 5. Okay, cosine of theta, adjacent over hypotenuse, is going to be negative 2 root 6 over 5. That means that secant is its reciprocal. Okay, so we're just going to flip that 5 over negative 2 root 6, and we will rationalize that like we always do. Multiply top and bottom by root 6. Okay, to give us a simplified answer of 5 root 6. Now the denominator is going to be negative. It's 2, and then root 6 times root 6 is 6. So negative 2 times the 6 is going to be 12. Okay. And then the tangent of the angle, opposite over adjacent, 1 over negative 2 root 6, which we will rationalize again. Top and bottom times root 6. We'll simplify to become root 6 over, and then again, negative 2. Root 6 times root 6 is 6, so negative 2 times 6 is negative 12. And you may see the negative sign just in front of the whole fraction instead of the denominator. It's all equivalent. And then cotangent will be the adjacent over the opposite. So negative 2 root 6 over 1, which is just negative 2 root 6. Okay, so basically with these, you're just going to want to, again, plot in the correct quadrant, use the conditions to figure that out, and then go Pythagorean Theorem to find the missing side length, and then just kind of use your SOHCAHTOA and their reciprocals, and you can get all the trig ratios for the angle.